This is going to be part 3 of our little discussion about gravity. In part 1, I went over the insurmountable problems which large dinosaurs would have trying to function in our present gravity. In part 2, I went over the two most common ways which theorists try to use to explain a recent change in gravity. These would be like air, which was close to being buoyant, and then expanding Earth theories. I have reasons for rejecting both of those, and I went over that like in the last part of this thing. It's like there simply hasn't been time for Earth expansion. You know, you're not talking about 65 million years anymore. You're talking about a few thousand or a couple of tens of thousands of years at the most. So that you end up in a situation where you need a new theory of gravity, something which would allow you to try to explain why gravity might have been attenuated in the recent past on our own planet, and also what there might have been going on the Earth like 6, 8, 10, 20,000 years ago, which would have attenuated gravity. Okay, you need some kind of a theory of gravity which can deal with that. Albert Einstein tried to describe gravity as a four-dimensional differential geometry thing, and you cannot start with that and believe that there could have been any kind of a very large change in gravity on the surface of our own planet very recently. And there are a number of other things which that doesn't play well with as well, right? You've got like these experiments, that doesn't play well with the idea of humans being able to control gravity. And yet we're reading about things like these experiments of Eugene Podkletnov's, in which rotating superconductors actually do produce a measurable decrease in gravity. And Eugene Podkletnov has gotten to be much more difficult for Westerners to talk to over the last 10 or 15 years since the arrival of Vladimir Putin on the scene. Right? Why is that? That's partly because you're talking about the possibility of a gravity beam weapon, which would be your ideal anti-aircraft or anti-missile weapon. A laser weapon simply would have problems on a rainy or cloudy day, right? Whereas gravity daisy chains, right? I mean, no amount of cloud cover would affect a gravity beam weapon. I mean, that's the basic thing that you're looking at with that. But again, there are a couple of reasons for just rejecting Albert Einstein's notion of gravity and what gravity amounts to at this point, right? I don't have any kind of a 100% solution to this problem. I don't have anything which I'm just completely and totally happy with. I've got something which is more like a 95 to 98% solution, which I think is going to have to do as a working hypothesis, and I'd like to explain that and what all is involved. Okay, this started a number of years back. This is Ralph Sansbury's theory of gravity, and Ralph Sansbury died a couple of years ago, was the man in charge of the classical physics group in New York, and he basically described gravity as being an electrostatic dipole effect rather than a basic force in nature. And the interesting thing about Sansbury's theory is that it isn't grandiose, right? It doesn't start off looking for some sort of a theory of everything or looking for any kind of a back-of-the-book type solution to questions about gravity. It starts off with a very mundane kind of a study of currents moving through wires and generating electrostatic fields transverse to the wires, right? Which shouldn't happen. It's a very, very small effect, but it's still measurable. And when you reverse the current, the electrostatic field reverses. So you've got something very interesting on your hands with that one. And Ralph Sansbury's explanation of how that works is exceedingly elegant. Okay, for the last 100 years, we have viewed subelectron particles, electrons, neutrons, protons, as being point particles. We used to, early on, 150 years ago, we viewed atoms as being point particles. That's what the word atomic means, right? But in real life, there's no such thing as a point particle. Anything which is real takes up space, right? And Ralph Sansbury described an electron as being not a simple point in space, but as being a small orbiting system of its own with at least two particles, that is a central particle and at least one orbiting particle, the charges of which sum to the charge of an electron. And he actually computed the necessary velocity for subelectron particles. He calls these things subtrons, right? And that velocity would get you from here to Andromeda in a couple of seconds, right? So it's a velocity which is gigantically greater than this thing which we call c, which is the speed of light waves, the speed of propagation of light waves. And what Sansbury claimed was, and it's perfectly logical, and in fact is giving real physical explanations for electricity and for electrical effects. I mean, it's always something. I was a math major in school, right? I mean, I always had an easy time visualizing physical things. Was electricity always seemed as if I was being asked to believe in magic, right? So Ralph Sansbury has like non-magical descriptions of electrical things, right? He says that basically at rest, without any forces in the picture, that an electron as an orbiting system would be spherical, right? But that when you subject the same electron to a force, which could be a voltage across a wire, then that electron is going to be pulled into an ellipsoid rather than a sphere. Now, a sphere doesn't represent any kind of electrostatic dipole, whereas an ellipsoid would. Okay, and the same voltage across the wire is going to polarize all of these electrons on the wire into ellipsoids, which are all oriented exactly the same way. It's going to be polarized, right? So that, you know, just in their hundreds of billions and whatever, it's like they're going to create a force which you can or electrostatic field which you can measure. And of course, when you reverse the current, that's going to reverse the orientation of all those electrons and reverse the field. So that's Ralph Sansbury's description of electrons and of currents creating electrostatic fields. Now, he claims that what gravity amounts to is similar. He claims that in the case of gravity, you've got spin forces which are pulling electrons into ellipsoids which are radially oriented, okay? And basically the electrostatic fields which that creates integrate to what we call gravity, right? I mean, the mathematics of it does work. And this is the point at which I would have to tell somebody that I don't quite have a 100% reading on this one yet. It's like the spin forces which act on a particle or a person on the Earth come in three flavors, right? It's like a person on the equator of the Earth is moving at 1,000 miles an hour due to the rotation of the Earth on its own axis. That doesn't seem like much, and that's not going to buy very much in the way of gravity, particularly at the poles, right? You've also got the problem of Venus, which doesn't rotate very much at all. It doesn't spin on its axis very much at all. You've got a much larger motion of the sun around, or of the Earth around the sun, which is more like 67,000 miles an hour. Okay, and then you've got a still much greater spin force, which would have to be involved with the motion of the solar system around the galactic center of the Milky Way, which is more like 500,000 miles an hour. Okay, so that somehow or other, in order to make this picture of Ralph Sansbury's work for gravity, you have to be talking about all these forces, not just one or two of them. Okay, and again, this is the thing which I would recommend as a working hypothesis at this point. That will buy you the idea of gravity being attenuated in ancient times by this static surface charge of the Earth in those days, which is something you get from the thunderbolts group and from the electric universe theory. You know, that you have this shish kebab alignment involving a Birkeland current, and you really did have static electricity in the Earth in quantities vastly greater than you observe today. Okay? Basically, what Ralph Sansbury is saying is that like gravity amounts to a kind of a first cousin of gyroscopic force and also of the kinds of things which you see in baseball. The spinners, sliders, sinkers, the things which move in a straight line more or less until they're about 15 feet from the plate and then just dive and sink, right? There is a video which you can watch on YouTube which is called Anti-Gravity Wheel, in which you have a number of people at the University of Sydney in Australia who conduct a very cute little experiment where they have a 40-pound flywheel on the end of what looks like about a 3.5 or 4 foot long rod with bearings on the one end, right? And they spin this thing up to 3, 4, 5,000 RPM, right? Without the wheel moving, then they've got like the one physics department nerd and then one of the jocks at the school. Neither one of them could do anything with this wheel, right? I mean, they can't, you know, they can't lift the thing easily, and they certainly can't hold it from one end and hold it out, right? As if, you know, as if that was an easy thing to do. Whereas they no sooner spin this thing up and it gets to be easy to, yeah, it gets to be easy to use. Even the nerd can hold the thing over his head quite easily. And they claim that this is due to gyroscopic precession. But I noticed that the one part of the experiment which they don't do would be to conduct this little experiment while they're standing on a scale, right? And, you know, it might be that it would go on, you know, that the apparatus would go on weighing the same as it did. Or it might be that they're a little bit worried about what the physics professors might have to say if they were to do that. At any rate, you've got a sort of an interesting picture sitting there. That's going to have to do it for today. Bye-bye.